Okay, here we got is my finished adjustable circuit breaker. What it does, it allows you to adjust. It's like a circuit breaker that can have adjustable currents that it can have through this variable resistor right here, this potentiometer right here, and what it does is this here is a comparator, and it comparates it between the voltage from the shunt resistor, which you can figure out the link in the description to show you how to make a shunt resistor for free. And right here, whenever it compares it, and the thing is, and the shunt resistor's current more than what the set current is, which actually just works as a voltage converter, converts the current to a voltage, since it has to be a voltage for a voltage comparator. That will compare it. Once it compares it, if it's shunt resistor that's high, it'll switch on this transistor. This transistor will switch on this relay. Once that switches on, it latches it and it breaks the connection between your N and that minus N, between the minus N of the relay. That's where you hook your load on. Should be load minus load. And that's your load. This relay, this circuit breaker is polarized. You cannot put it backwards. So what this here must be towards the negative part of the load. This here must be part of the positive part of the load. In other words, you get this marker out. In other words, let's say you have a battery right here, and let's say this is your load. This goes to plus N, then this goes to minus N. Like I got on here, so the plus N will go right over to here, the minus N will go right up to here. That's what the circuit looks like if you have a load in the battery. This here, right here, this formula right here, the VI, that's part of the variable resistor right there. That's how you figure out what voltage you must set it to in order for the current to be, the maximum current to be that. So what you do is you take VI equals I times R. I be a current and R is your resistance that the shunt resistor is. This one was 0.02, this was 0.225 ohms resistor. Okay? I had to put this voltage follower from the the op amp right here, instead of going to this op amp directly, I had to put a voltage follower on it. Why was that? Well, because when I was changing the currents on my power supply, I went to the input right here to test it out. What happened was, when I put more current in it, the voltage would increase or decrease, and I changed the current on it. So what I try to do is I thought about maybe it's a load thing on it. Maybe it needs to have a buffer on it that buffers it, and it did. That was the problem. I needed to put a buffer on it in order for it to keep it from the voltages from changing. Capacitor is I don't know if it's there or not, but I put it there because I think it needs it. It prevents it from oscillating. You should probably put it there anyway if you don't want it to ever oscillate anyway. It's a good thing to have. Let's see, anything else here? All these grounds here connect together. And they also go to the negative voltage of your power source of whatever you use to power this circuit breaker with. I use the 9-volt power supply. Even though my relay was 12 volts, it works on 9 volts, come out of a van, and it works on 12 volts, 5 9 volts. Oh, I decided to use that power supply for it. This took a lot of hard work to do and stuff, so I'm glad that people on the electronics chat on DaleNet was able to help me with this. Okay, let's take a look at it right now. Right here we got it in a case. This is it. This part here controls the current that you want. Want the maximum current they want to do about it, switching off. They're switching on the relay and turning off the load. Maximum current for it is so it won't. So let's adjust it. You can adjust it different currents by the voltage out. And this here would monitor the voltage on it. They monitor the output of this thing here. So that there can go to your meter. This here tap off right there between this pin and the ground. And that's how it works. There's this transistor here. It doesn't have to be any kind of transistor. It can be any kind of transistor you want. All it's just going to do is just switch on that relay so I can latch it whenever that thing goes high. Only time it will go high is if the voltage comparator compares the voltage and sees that it's overloaded, then it will go. They change it to a 1 and make it all latch. I have no idea what op amp I'm using. I'm using some kind of op amp, but I like the way it works. Anyway, Okay, it's all the way to trip. Let's see what current we have it set to. I'm going to adjust it down to, this power supply, nice power supply. Let me adjust the current on it too. I can touch these two clips together. Good enough. Okay, we can then change it, go down. That's going up. We'll leave it at that. Now let's plug this into here. Because it's all the way tripped, I'm gonna have to reset it. You can put a switch between the power line on the relay and it will push button or a switch and it'll break the connection. Break the connection between it, then it will reset. A normally closed button will work for that, but I don't have one. Now it's time to reset it. Okay, I heard it click, so it's resetted. And we are on there, it's still got our 290 milliamps. I'm going to set the let's set it to handle an amp power. I'm going to measure the voltage there. Ooh, it's well, in the wrong setting. Uh-oh. We should always unhook this lobe before setting it, so it doesn't trip on it. I heard it go click and then it shut off. So we're going to set it to these meter probes on there. I think around 116 will do. 166 millivolts should give us about an amp. With a 225 milliohm resistor. Let's turn it on. We adjust the current to go up from there. Ah, I did. You just heard it. That was at 780 milliamps. It's a little bit off, but it did go. You can use this on it. They have, I'll tell you about this, there's this one, the Power Switch Tail 2 has one as a kit, but the thing is, a kit is kind of hard to do because it has surface mount components on it. It may be hard to solder it. And this is cheaper than buying that, too. They want like $20. It's just parts you get for this, it can be less than that. Less than that, or if anything, be about the same amount as what you get from there. About. That's why I decided to make this, because I thought there had to be a better way to do it. Since also, Juan Sutherland off of Glasslinger off of YouTube said he had one that for all of his equipment, his test equipment and stuff like that. So if the draw too much, it just blows that fuse, and then you can change it by different settings. Well, that's it for now. So I hope you enjoyed this video. Thanks for watching. Hope you like it.